And I guess as we start to use more technology, these will become readily available. What's holding a lot of these back at the moment is patents rather than actually making them affordable. So Stratasys actually hold the patents of quite a few of these, but for example when you start to get to material jetting, it brings a whole new raft of technology within the grips of what we're actually doing. So in the next 5 to 10 years we're going to see an explosion of different tech that's going to hit the desktops and enable us to print parts quickly and easily. So FDM, this is one we're all familiar with. Basically it's an automated glue gun. That's all it is. It's quite simple, it's computer controlled, and I think everybody who's printed from small parts to large parts were quite familiar with this. There's another technology that's very popular, and I think most of you may well have seen parts that have come out from this. This is SLA or DLP. This I find quite magic. It's a big vat of resin that's cured through light, and what it does is it lifts the part out of the resin. The advantages of this one in particular is the resolution is a hell of a lot better. The quality of the prints are a lot better than FDM. The challenge is probably scale and resilience. These tend to be slightly harder and kind of less flexible. And these are some of the other technologies. I work for a company called Rico. We make that big beast over there, the SLS, which is about £500,000. They won't give me one and they won't let me play with it. I have tried to convince them to print a whole dome on it, but they want about 400 quid just to print the dome. So it's, but what that does is it builds out of layers of powder. But there's a whole bunch of technologies. The one that I'm really interested in is that inkjetting. For those that are not familiar with that, that's Stratasys. They do a series of printers, and these are the ones that typically use to manufacture what you see in movies. The Iron Man suits were printed on that kind of technology. And what it really is an inkjet printer as we would understand today, but the ink is actually cured using ultraviolet light. It's a very quick way of building parts up. It's got a hell of a lot of materials, and when the patents, I think about 5 or 6 years, start to release on that, that will change the way that we certainly produce parts. So it's quite exciting, I guess, on what's coming ahead. Materials, there's a whole bunch of things, and I think, again, you may be familiar with some of these. I personally not found, I'm tripping over a wire. I personally not found one material that works 100% for what we want to build and what we want to create. Historically, my favourite has always been ABS. The reason that's set up there is a bugger to print. It shrinks, it warps, it bends, it needs a heated bed, but you can stick it together with acetone. It sands extremely well. And most of my first 2 droids that I designed, I built in ABS. The challenge we had then was the fabulous S5, the CR10, which is a 500mm bed that lets us do single print, and that's pretty much put ABS to death on that scale, purely because of the warpage. So I moved over to the PLAs, and we know the challenges with PLAs. They're brittle. They tend to have very little shrinkage, they're easy to print, but they do warp at low temperatures. By warp, I mean it can melt in the sun, literally. I think Sam's lost a dome to PLA in the past, and bright sunlight. So PLA Plus, there isn't a standard filament for that. I use Sunlu for the 3-ring dome, which you can see over on the left, and it's actually pretty strong. It's got a lot more flexibility. It does sound quite well, so I'm becoming quite a fan of the PLA Plus. The other one to kind of push out on that is PET-G. That's one that I use really for smaller parts. The challenge with PET-B is it is really difficult to find anything that glues it properly. I've literally put araldite on 2 surfaces and you can pull them apart. Nothing sticks to it incredibly successfully. If you sand it and you use araldite, it does just about stick. You can also use super glue with baking powder And again, I've had some success with that, but I'm not confident I can build structural parts that are glued with PETG. So at the moment, I'm really quite keen on the PLA Plus, and of course you can use super glue to stick that together. What I've included on these, and I'll share these through the club, there's kind of my temperatures. You've got the temperature of the print head, temperature of the bed. I have to get asked a lot around print settings on what you'd recommend for various printers and how you tune them in. And to be honest, there's so much stuff out there that, I mean, I can give you my opinion and my view, but I'd recommend you join some of the 3D forums. But the materials are constantly evolving. I suspect that the PLA Plus will continue to evolve, and that will become, along with PETG, the standard that we use. Nylon I use for the wheels. I think my droid is 100% printed, including all the drive trains and right down to the battery hoses. And nylon I use a lot for the wheels because it literally is bomb-proof. It doesn't wear. It's really solid. And the bottom one, TPU, which is flexible material. I think for those that follow some of the stuff that I've done, I use that in dry belts, in wheels and tyres, and also it's great for creating servo hinges because you're not going to create mechanical parts. So really getting familiar with the materials and testing the materials on your printers, I'd recommend having a few in your arsenal, rather than just sticking with PLA. A little bit on software and files. Again, I think you may be quite familiar with these. I'm just going to jump into Fusion 360 in a second, because that for me is probably the best tool for what we do. If we want to create mechanical parts, hard surface parts, Fusion 360 is fantastic. Mudbox is more of an organic modeler, but there's some great software out there. For those of you who haven't played with design, Fusion 360 is free to hobbyists. Don't sign up, don't pay for it, you have to jump through a few loops, but if you're earning less than £100,000 out of it, it's classed as a hobbyist, which I think is virtually everybody, and you'll have an evergreen license on that Fusion 360. Grab it and have a play with it, because it will really pay off in creating little parts and things that you may need. I recently created a stand for a Christmas tree that I lost, actually printed it out yesterday. Once you kind of get into designing, you'll find all sorts of uses in the home for it. The second bit then is models. There's two kind of files on there, STLs, which are meshes, and as you can see that picture, if you get an STL, a question that gets often asked is how do you edit it? They're incredibly difficult to edit. They're the output of design. The STP is the original model. You can get an STP, it's got hard surfaces, you can cut it, you can slice it, and you can do things with it. The STL is very difficult to do. But obviously, a lot of the designs that I do, I will produce the STL for people to print, but I also share a lot of Fusion files and the STPs for those who want to modify it, change it, tweak it. My view, I think, in the spirit with the club, is that everything that we do, the more we share and the more we evolve together, the kind of more advancements that we see in the hobby. Then you've got the slicer. There's a bunch of slicers on the software, and what they really do is they take that mesh, which you can see at the top, and they slice it into very thin layers, and it's very specific around your printer, so it uses the temperature, the settings, how you put supports, and really all the detailed instructions that your printer needs specifically to print that. Those are really the main pieces, and then obviously you've got the outputs of the print that you've created. So, just some links. I would, again, we'll share these, but feel free to grab all the software up there. Obviously, there's a bunch of STLs and files on Astromech. If you go onto my page on there, in the About text, there's a link to the OneDrive, and it's literally got all of the output, free to whoever wants to use it. You can do what you like with it. Thingiverse is a great place to get files from. The challenge you've got with Thingiverse is a lot of the quality on there isn't fantastic, and you can't be 100% guaranteed that it's going to be accurate or it's going to work. Design software, I mentioned Fusion 360, I'll go through how we use that just shortly. There is another software that you'll see bounded around a lot called Blender. Blender's an open source, completely free software, but the learning curve on it is years. I've picked it up about 3 or 4 times, tried to use it, struggled. I can just about do some basic stuff, but I would strongly recommend you play around with Fusion. On the slicer front, there's a bunch on there. You can use Cura, Simplify 3D, the slicer. My personal favourite again is Simplify 3D, but it's not free. I think it's about $150. And I guess Cura is getting very, very close to the outputs of Simplify 3D, if not slightly, probably got ahead at the moment. So there's your links on there, but I would say don't pay for anything. It's all that kind of stuff is available free. So what we'll talk a little bit now is about actually designing for print. So once you start to get your grips to the basics of Fusion 360, there's 2 types of modelling. On the left you've got soft surface modelling, so that's your sculpting stuff, that's your busts and your characters and all that kind of thing. And ZBrush is an extremely expensive piece of software, but very, very popular. Mudbox is relatively cheap, I think it's about 10 quid a month. And what you typically will use as a stylus and the 3D mouse, which lets you spin around in space, and you can sculpt in the same way as you would do with clay. I don't do an awful lot of that, and the bits that I have done, I wouldn't say I'm proficient at it really. On the right-hand side, that tends to be where I spend most of my time, and Fusion 360, that's hard surface modelling. For everything that we do around the Astromechs, around any of the kind of robot stuff, then Fusion 360 is brilliant. It's also fantastic for making functional parts. So, what I'm going to attempt to do here, holding a microphone and holding a mouse, is take you through the basics of starting off with Fusion 360. And what I want to get to a point with is that at least you feel that you would to install Fusion and be able to create some basic parts. So the part that I'm going to sketch out live on stage with a microphone in one hand is, I'll start with a foot shell. Obviously it won't be accurate, but I'll just give you kind of an idea of how we do that. So this is your basic Fusion 360 interface. The one thing that will really switch you off from using it, I'll just show you a little bit of a secret feature on here. If you right click on document settings, and I don't know how much you focus that is, but at the bottom of right at the bottom of document settings you've got do not capture design history. That switches off a function within Fusion 360 that allows you to sort of go back through the history of what you've done and go down different design paths. I would highly recommend you switch it off. What it does is it does all sorts of really weird and unexpected results when you're modelling. It stops you from copying and pasting objects from one design to another. So by all means, if you want to learn how to use Fusion, by the book, and by the book I mean it's literally doing constrained sketches. There's lots of tools out there, lots of YouTube clips that you can read through to learn it. What I've tried to do really within this example and some of the videos that I put together is to make it simple for us which just want to create objects. So first thing is always do not capture design history. The second thing to switch on is the origins, and the origins are these 3 planes here. So what we're going to do now is we're going to design a basic foot shell, just to give you an idea of how we would do that. The first concept in 3D design is a sketch. You can create objects here So you can create spheres, boxes, cylinders, but really they don't have a lot of use in creating something from scratch. So we always start with a sketch. A sketch is very simple. All it is it's a flat, two-dimensional design. If you move around the space on these axes, you can choose which. It's not really coming up very well, I don't think, on the screen. I'm going to choose to do one on the Z-axis on there, and when you click on it now, I've now got an area that I can start to sketch out. So as I said, I'm going to do a foot shell. What I will do is I'll draw just go back on that. So if you go onto sketch, you go onto rectangle. I'm going to do a 2-point rectangle, and very simply, what I've drawn is a square. On my screen, that's kind of filled in. Obviously, the projector's not showing it up as well as it could do. When you've got this square up there, what you can do, and I'll just kind of zoom in there, is that's a sketch. It's in 2D space. So the first part of a foot shell is I am now going to create an extrude. Extrude, within any sketch that you've got that's got a full perimeter, what you can do is you can then pull out, and that's where you've made your first part, your first block. I'm not going to go accurate dimensions here, but typically you'd have blueprints to the side so you can start to look at that. Press OK on that, and so what we have here now is just a simple three-dimensional cube, and we can print that out as is. On Fusion, I'll just take you through some of the ways of moving through the space, but again, load the software up and play with it. The scroll wheel allows you to zoom in and out. If you press the Shift key and the middle button, you can start to spin this round. I'm not pressing the Shift key and the middle button because I haven't got 3 hands. But what we've created now is we've created a solid three-dimensional object. So the first part of creating the foot shell now is to carve this object up. So it's a bit like how you would do in wood. And the way that I do that is, again, sketch, click onto lines, and whereas before it was looking for any of the planes, I can now select any flat side of that object to draw lines onto. So I just click onto the end of that box, and what I'm going to do is I'm going to take an angle off, just like about there. It doesn't really, you don't have to design the whole foot shell. What you can actually do is almost chop bits off as you would do if you were carving wood. And so what I've got now, if you can see, is I've got a line there, I've got the main object, and if I click on Modify and Split Body, this now gives me the opportunity to make a first cut. So if I click that body, I click on the splitting tool on that line, and OK. What I've actually created now, what I've done is I've split the whole body into 2 pieces. Within Fusion, this is where all of your items that you've created are actually stored. So if I just go into sketches now, these are the 2 little sketches that I've created. That one's a line, and that was the original sketch. If you remember, it was the rectangle that we extruded this from. By default, it will switch those sketches off. It will make them invisible. You can go back and reference them. When we extruded, what we created then was a body, and that's a solid object. This is what we print. And you can see now from that cut that I did, I now have 2 bodies. The piece that I've cut off from the main body, and I can literally click on that and delete it. So now this is where you start to get your design for your foot shell. Again, similar sort of. Next stage is I'm going to click onto sketch, move fairly quickly just so you get a gist of it. Once you get an understanding of how the basic functionality works, then you can start to play with some of these tools. So flat space again. I'm just going to chop a line down to about there. So what I want to do is I want to cut that and a little bit of a curved piece out. What I'm going to do then is I'm going to do I'll do an arc from there to about there, and I'll stretch that arc out a little bit. So if you can see now, I've created a single line that starts to do that second part of what we want to do around the foot shell. So I'll stop sketch, and then exactly as we did before, and this to be honest is where I probably do most of the basic carving of the designs before we start to add details. So modify, split body, highlight the body, hit the splitting tool, and if you can see what's happened now is it actually follows that line as a cut. So we take out that little curve at the bottom, click OK, and if you look on here, we now have two bodies because we split the bodies into half. Right click on that body and delete. So what you started to create there is the basic foot shell. So if we wanted to continue doing that, we could then move to this plane here, so we can put the angles in that we're used to. Again, sketch, line, and I'll chop a little bit off about there. So this is not accurate. And just for time, I'll throw another little line through that. These lines as well, by the way, if you've got access to any of the original files or any of the original designs and you want to cut these up for your own print beds, these kind of things are ideal really. So modify, split body, let's hit that body and use that line again to chop that corner piece off. Click OK. And what I'm going to do now is modify, split body, and just take the other corner off the line. So you can kind of get a feel now for how, when you start to build things through, we can then remove the bodies, delete that one, and delete that one. And this is where you then started to get the basic design of your foot shell. And we can add further details just literally by creating more lines, and I'll just put a little bit of a, I don't know, I'll just put a little bit of a detail in like that. So, same thing, modify, split body, and click OK. And then I can take out that place. So very quickly what you're creating is the basic frame that sits behind it. When you're happy with that, and I know this is a terrible example of a foot shell, you can then start to look at hollowing that out ready to print. There is a function called modify and the shell. And again, all you really need to do is start creating objects and playing with some of these features. But what shell does is you will select a face, which I'm just going to select the bottom of this face. You select a distance, so we'll do that 3 mil. Click OK, and then what that has actually created is your basic foot shell. I mean, obviously, you would probably spend a bit more time getting it accurate and tweaking, chopping more bits off. But hopefully that's kind of give you a little bit of an idea on where you get started in doing this. There's lots of features then that allow you to add extra details within that. I'll just show you quickly, so to create perhaps some details on this face. We will sketch. This time we're going to use something called project. And what project does is it allows me to select a face and any feature or any body that you've got, you can start to add to that. It will create a sketch from that particular feature. So what that's created, if I just hide the body, I can show you. What that's created is it's created a sketch that exactly matches that face. And if you click on sketch and offset, and again, I know I'm going quickly with these tools, but I just want you to get a feel for the sort of things that you can do. I can offset that, and I can start to add extra features. So if I click on something like modify, and rather than split the whole body, I'm just going to split the face now. I'm going to select this face. The face, the body will actually cut right the way through like a block of wood. The face will just actually create a cut that affects just that particular area, which I'll show you a little more apparent. So you can see it's not cut the whole body, but what it's done is that little sketch that I've done, it's created a cut of the face that will let me then add extra detail. So if I go into modify and press and pull, I can now add extra details on. And this would typically use where you've got details on domes and that kind of thing, really, to add extra pieces. In this case, it lets me do the full cut through, so I can start to add extra panels. If I just pull it back under 3mm, so I don't actually cut right the way through it, I then start to get details on the model. And literally all the stuff that we create is by just going through that. Every so often, what I tend to do is tidy the sketches up, so I'll delete the sketches, I just stick with the bodies, and when I want to modify, update or change things, what I will start to do is just sort of edit those, edit the original files. Fusion also then allows you to save the files. It's a cloud-based saving, so if I go into all of the stuff that I've got here, these are all of the designs that I've done to date, and I can save this unready file in here. But the real advantage of Fusion is you can then share them with other people. We can share them with the club, so people can then start to add, modify, and change the designs and basically enhance them. So as a tool, it's very, very powerful in terms of collaboration and creating things as much as it is with actually designing. So that's your basic foot shell. What I have got, I had a big bag of pieces that allow you to see each individual cut, but within this kind of space it's a bit difficult to go through that. But if you want to have a look through those in a little bit more detail, then pop over and give me a shout a little bit later on. The other thing I will quickly show you, just do one more design, and then hopefully that's giving you enough to start the appetite in starting to use Fusion. The other thing that I will say is, obviously through Facebook and on the forums, I'm fairly kind of prolific in posting on there. But any questions you've got about Fusion, there isn't any stupid questions, anything that I can do to support and help people getting started, then by all means drop me some questions. The other thing that I've got, which is on the Patreon site, is about 8 videos that go into quite a bit more detail on this, that take it from doing some basics like we've just seen, right the way through to an R4 dome, which you see on the single print ones. So there is that also available. If you want links to that, just drop me a line. It is on the Patreon site, available to patrons, but within this group, you can have it, just play with it, and all of the models are available there. What I will do now is quickly go through a dome. I'll just do a very quick, probably do an R5 dome. They're fairly simple. And just, most important thing, turn your origins on so that you can see the planes that you're sketching on. The second thing, and this is the most important thing, is do not capture design history. It seems counterintuitive turning it off, but believe me, it'll make your life a hell of a lot easier. So I've got the planes. I'm going to click on sketch, like we did before, and I'm just going to do it with a line drawing. This time, I want to do it on one of the planes. I think this was the Y plane that I've just selected. And what I'm going to do is I'm just going to draw half from memory, an R5 dome, roughly. So it might be, this is not going to look film accurate, but there we go. So along that line, I've just created the silhouette of what I want the dome to be like. And then what I've done is I'm drawing it so we've got a continuous loop sketch. So this is a two-dimensional sketch, as we saw on the previous one. A stock sketch, that's the half silhouette. Again, simply create, revolve. And what revolve does is it will take that sketch and spin it around an axis. The axis I'm going to set is the one in the centre. It creates a new body, I'll click OK. Honestly guys, it sounds like a shopping channel list. Honestly guys, it is that simple to create your basic shape. And then, like we did before, if we highlight that bottom face, click on Modify and Shell, and do 3mm, click OK, and you've got a shell of a basic dome. If you want to then add details, very, very similar to what we saw before, so we'll sketch some lines that we want to cut the dome up with. I'll add a little line at the top. So draw a line. I tend to do these little U lines, which is a line across, a line down, a line back, because it speeds up when I want to then cut the body. So I'm going to split the body, highlight the body, and I'm going to use that little U line. What it's actually done then is it's looped back on itself, so it's going to create two cuts. I can grab that corner to show you. So it's going to create two cuts, click OK, and there's your detail line. And then if you press and pull that, you can just pull that back a little bit, click OK, and you've got your first bit of line room for a dome. What you will find is as you start to split objects, it creates multiple of these bodies, because as we saw before, these are all independent parts. But again, if you click on Modify and Combine, you can then combine 3 parts back into a single item. And literally what you'll tend to do then is add the details, and that would give you a printable dome that obviously you can continue to enhance by cutting pieces off, pulling pieces out. There's a lot of features in Fusion, and this session we're not going to go through all of them. As well as the model mode, which we've been using, there's a sculpt mode that it doesn't do the organic stuff like we saw before, where you'd actually create faces or skin, but what it does do is allow you more flexibility if you wanted to move on to doing stuff that wasn't basic geometric shapes. So there's a lot of tools in there. The other one to mention is mesh. If you did want to split an STL, the mesh workplace allows you to do that. And it's very, very simple. You just go into mesh, import your mesh, and split things like I've just done with the lines shown previously. So that's what I wanted to cover just on the basic interface on Fusion. I don't know if we've got within this group a way of sharing all of those video links, but I'm more than happy to do that. I'll have a chat with the guys afterwards to see. So I think that will hopefully take you from this first piece and then allow you to experiment a little bit further. So what I'm going to do is I'll just cover off finally a couple of points really just to consider when you're designing. The first point critically is you cannot print in thin air, so you have to find very creative ways of designing your prints. So if you look at the 3-ring model that I've created, things like the cutout details, that's what I keep mentioning is 70 degrees, but if you put a slight angle on things like the letter Y on cutting details, you get a lot neater prints rather than the letter T. The second one is very much about strength, and this is something to really consider, is that you are effectively printing like wood. So think of all of your prints and your designs very similar to wood. On the Mark II body that I did, I used a lot of cross grains like you would do in wood to actually create the extra strength. On the 3-ring one, you cannot do that, because the 3-ring one is literally slice on top of slice on top of slice. So what I've done with the 3-ring one is I've added 4mm studded threaded bars that go through it to actually give it that other side of the strength. But really consider, if you're printing an aerial, for example, you print it flat, you wouldn't print it stood up because it'll just snap. So just think of it in that way like wood. Third one, no plastic is better than plastic. Wherever possible, create holes. It's not artistic, and what it does do is it rapidly reduces the amount of filament that people have to use. The 3-ring body was, I guess, as well as actually creating something that we could print on the big printers, what I wanted to do is take as much plastic out as possible. So the original one was about 8 to 10 rolls to actually get the body and the skirt, and that one's down to about 4.5. So when you're designing as much holes as possible, I guess the other thing that I've learned a lot from printing is that actually it's a lot stronger than what we think it is. So recreating the original designs for that real strength, there's a lot of things that we can do with 3D printing, because the skin itself, when it's actually as part of the print, adds an awful lot of strength. The fourth one is just do a little bit of research on some of the stretch limits and tolerances. That 70-degree overhang has really changed massively how I design domes now. I was talking before, I think, with Giles on the R7 dome, where the first one I did is I put little tabs in there to provide supports all the way around, and they're an absolute bloody nightmare to get out. They really are horrible. So apologies to everybody who spent time sanding those out. By simply putting 70-degree angles on, rather than it going in at 90-degree angles, they look exactly the same, but you haven't got any supports at all to remove. Bridging's another one, is that the molten plastic will actually go across quite a large gap, so use bridging to your advantage. And the last thing to consider when you are designing is if it's not an instant fit. You do need a gap between parts, and the reason for that is the way that 3D printing works is it squashes thin layers of plastic, and typically it'll stick out between 0.15 and 0.2, and so you have to leave gaps to create the jigsaw pieces or the dovetails that we use quite a lot. Fifth one, I failed on this miserably when I started, and that was because you just build it for yourself and you know how to assemble it. I don't know if anybody's ever seen the stuff that I did on Thingiverse. I did some skins, and literally it was about 50 pieces of little square bits of plastic with no instructions. So it was an ultimate torture test, a bit like those baked bean jigsaw puzzles that you see. So what I've started to do, what I do on most of them now, is I add numbers really so that you can simply sort of go around, in other words, design for other people. And I guess the other one is actually designing for the printers that we have. Everything that I've done probably up to this point has been for a 200mm bed. I get loads of requests on, can you do it to 300, can you do it to 350, can you do it to 400, can you do 450? And what I end up doing is, rather than designing, just spending all my time either chopping and slicing or sticking things together. 600 bed really works for most. 500 bed for the big boys, but actually, you know, the thing is, if you can get your head around some of the basic designs and grab hold of them, you can do the joins yourselves, you can cut them to whatever printer you want to do, and ultimately that makes all our lives easier and gives more options for builders, particularly if you share them. Quickly touching on some of these, I think this is some of the print quality issues. What I would recommend is the 3D printing forums. You know, the place really to ask all of these questions is on there. They're a great community and very, very helpful, similar to all of our guys. So really get in there and get to understand and how you tune your specific printer. There's forums for the CR10s, for the Prusa's, for all the common brands, and then there's common 3D printing ones. This is something that I found recently. I always used to print on dot 3 as a layer height, and what happens is the nozzles in most printers, and you can have different size ones, but the general size is dot 4. This is simple physics. If you are layering plastic on top that's coming out of a dot 4 nozzle, it's not going to stick to the layer that's there before if you put it at the same height. Dot 3, you create a smaller surface. Dot 2 and dot 1 is where you start to get a lot more strength. So there's a big difference in strength between dot 3 and dot 2. Dot 2 does take a lot longer to print, but what it does is it gives you a lot more resilience. I used to print all the ABS stuff on dot 3, and it was strong enough. What I tended to do is coat it with acetone to stick the layers together, but certainly with the likes of PETG and PLA, I would recommend the dot 2 or the dot 2.5 to give you that extra strength in bonding. Finishing, everything that we ever post, you always get somebody who wants to say Sam, fill, and repeat. It is absolutely painful. I love Sam to bits, almost carnally for one reason. He gave me spray putty. Spray putty is outstanding. It's superb stuff. It can cut down the preparation time massively, and you get 2-3 coats on it, rub sandpaper over it, and it's pretty much ready to paint. Whereas previously we would be sanding, filling, sanding. So I think it's that popular, it's generally sold out now at most times, particularly, is it McCormick Tools?
Yeah, I've spoken to them recently to get more stock in.
Yeah. It's like $250 a spray can. I think I bought them in 15s. I know Sam probably buys them in slightly more quantities, but that stuff is incredible for those of you that are doing a lot of 3D printing. Rapidly speeds up the finishing process. And I guess that's it really. Just what I really wanted to do is give you that basic introduction. The last time I did this, I had a little bit more of a kind of a space to do the demonstration, so hopefully it's not been too clunky where we did the Fusion 360 stuff. But what I will do is we'll find some way of sharing the videos. It'll take you from doing the basics right the way to doing an R4. And please, just don't be scared of it. It's very, very easy. And if we all get to the point where we can start to do that fusion designing, then we take it a little further forward. So that's me done. So thank you.